then was called Tigertronics, come up here and do a presentation of their competition robot. And other than for the 2 years around COVID, where you guys really didn't get a chance to do much, you've been up here every year, and I really appreciate that. I really enjoy seeing how the how each year's program differs, how you have adapted your robots to for the new challenge. So at this point, I'm going to turn it over. I'm going to turn it over to you, Drew, and then we'll let you take it from there. So hold on.
Hello everyone, I'm Drew Williams, the lead mentor of Southern Tier Robotics, previously Tigertronics, and I'm here to let the students give a presentation about the club and the team and what we do every year and how we do outreach events to the community and stuff like that. I'm really just here for the intro. I'll let the students do a lot of the talking today. Near the end, feel free to ask any questions you have, either technically about the robot or about the team in general. I'll pass it off to Ann. She's the business lead on the team right now, and yeah, thank you.
Yeah. Hello, my name is Ann Coleman, and I'm the team's business and media lead for Southern Tier Robotics. So our team right now is in Vestal High School. We are using their shop, and we're their robotics team. What our team does. So we are a FIRST robotics team. FIRST is a international robotics organization that does robotics programs in schools. They have robotics competitions that start in kindergarten and go all the way up to 12th grade. So we are in FRC, which is the FIRST robotics competition, which is the highest level of their competition. This competition has kids from 9th grade to 12th grade, and there are teams all over the world. There are 2 other levels. There's one level that has kids in elementary and middle school, and then there's another level that's middle school and high school. We were formerly Tigertronics. We moved to Vestal after the pandemic, and between UE and Vestal, we have been running for 17 years. This is our team photo from our first competition this year. We had a lot of people on our team that were there. There are a few people who are missing. Our competitions are really an amazing space for us. We learn a lot. We see the other teams' designs. We work with other teams throughout the competition. We spend a lot of time working together as well. It's a really team effort. Our team has about 22 students on it. We're made up of all different students. We have students who are really into the tech and engineering classes at Vestal. I am more do art classes, and I'm not as into the engineering stuff, but I still help build the robot. I still suggested design stuff, and I still do a lot for the team. Go back. The students and mentors work together to build a really complex robot. We start our build season in January, and we have 6 weeks until our first competition this year to build and design from scratch this monstrosity. Our mentors are all professionals in the field, so they all have jobs in STEM. We have mentors who are engineers and software programmers and all over the fields, and they all help us and guide us in our design and our building and our overall careers and our aspirations in life. So right now we're in Vestal High School, and we work in the old wood shop there. We've updated it with new machines, so we have a really nice CNC now. We have software. We use CAD a lot. I mean, that's Anything else you guys want to add? We spend a lot of time learning CAD programs and how to use CNC and other shop tools. Our season runs, we start in September with a pre-season. We meet a couple times a week. We do prep for our season. We build any parts of the robot that are like pre-made or that are pre-made. So part of the competition rules is that we are not allowed to design anything or reuse anything we have designed. So pre-made parts like gearboxes and motors that we get from other people, other resources. Vex is a really big company that some people have probably worked with in PLTW classes. We get stuff from them that we have to assemble, so we do a lot of that work in preseason. We also go to a preseason competition that is last year's game, so we work continuously from the end of our competition season up until our new season to continue working on the robot, continue improving it, just to get extra practice with the improvement in the engineering of it. I'm not done yet. January through April is our build season. So in January, like early January, they have our opening ceremonies. Everyone around the world gets the challenge at the same time. So we all find out what the game is at the same time. We all have to design the robot and build it. Our team always starts, we have a couple weeks where we brainstorm and we build our CAD model, we improve it, we make prototypes, and then we have to build all of the robot and get it to competition, get it in working order. So once our competition season is done, we do more similar things to preseason. We prep, we teach lessons to new students. We make sure our shop is clean, get everything back in order. Sometimes things get messy during build season. We work fast. And then this year we went to competitions in Pittsburgh and Albany, but there are competitions all over the world. We always have international teams at our competitions. We had, in Albany, I think we had teams from Turkey, Taiwan, Canada, and Poland maybe, but yeah. So it's really an international experience. We meet lots of different people. We work with lots of different people. Yeah. So part of our building our robot is testing it. So one of the first things we do when we get our game is we have to build models of the pieces that we use in our game. So there's these big plywood things. So that's one of the field elements that's on the field when we get to competition. So we build our models and then we have to test it with the game piece. I have one right here. They're foam rings, which was part of our design challenge. And here is a video of our team robot testing our shooting mechanism. Yeah.
Let me turn off the sound.
Yes. So turn it off. So the first portion of this is auto. So it's all autonomous. It's pre-programmed. Yeah, we're good.
It's very loud.
It's very loud. We had to turn off the sound. So that was the point where our driver took over. Our drivers need a lot of practice throughout the season once we built the robot. It's a difficult thing. We have two drivers during competition. We have one who controls the movement of the robot, like where it's going, and another one who controls the mechanisms that are on the robot, moving the game pieces. So turning on our intake mechanism, which is in the bottom, sucks things up, and turning on our shooting mechanism here, and this one I'll explain in a minute once you've seen the game. You want to go to our next? Yeah. So this is the video. This is the video that we got shown in January when our game was released during kickoff. So this is what gets shown to everyone around the world. Along with this video, they release a rule book that we all have to read that's like a couple 100 pages. Okay. You probably want to turn on the sound so we can hear the rules.
Welcome to the 2024 First Robotics Competition Game, Crescendo, presented by Haas. 2 alliances of 3 teams each compete to score or play notes in 3 different field elements, amplify their speaker, get on stage, harmonize, and take the spotlight before time runs out. Alliances earn additional rewards for meeting specific scoring thresholds and for cooperating with their opponents. Robots start each match inside their alliance's starting zone and may be preloaded with a note. During the first 15 seconds of the match, robots are autonomous and can be programmed to leave their starting zone, play preloaded notes in their speaker or amp, and collect and play additional notes. During the following 2 minutes and 15 seconds, drivers control their robots. Robots collect notes from human players at their source and play them in their amp and speaker. Each time an alliance plays 2 notes in their amp, the human player can hit a button to amplify their speaker for 10 seconds. Notes played in an amplified speaker are worth more points than those scored in an unamplified speaker.
A human player may choose to play a note scored in their amp to cooperate with their opponent. If each alliance plays a note by hitting their cooperation button in the first 45 seconds of teleop, all teams in the match receive a cooperation point, which will influence a team's rank in the tournament. The number of played notes needed for a bonus ranking point is also reduced.
Robots are protected from contact by their opponents when at their podium, off the ground, and during the last 20 seconds of the match while in contact with their stage. As time runs out, robots race to get on stage and deliver notes through the flap and into the trap. Bonus points are awarded for harmony when robots on stage use the same chain. On-stage robots earn even more points if a human player spotlights the robots on a chain by scoring a note on the chain's corresponding microphone. The alliance that earns the most points wins the match.
So there are a lot of rules, and it's kind of a complicated game. Yeah, this one was a little bit crazy. Last year's was a little bit easier to follow. But it is a challenge to build our robot every year as the game rules are complicated. I know part of the challenge for us building the robot this year was picking what our focus was going to be, because there's so many different ways to earn points and there's so many different strategies you could come at it with that it was hard to pick how we're going to do it and how we're going to, what our robot design is going to focus on. But we did, and this is a video of one of our matches from Albany, Pittsburgh, Albany. So this is from our Albany competition. You want to play? Yeah. We are, I think we're red, yeah.
Drivers behind the lines in 3.
So we're the
2,
red
1,
team.
crescendo.
We're starting in the middle.
And it's showtime as Southern Tier Robotics with a successful shot into their red speaker already. And it seems Espresso wants to line up to follow suit. Will they get it in time? Well, in the meantime, 2053, Southern Tier already grabbing another note from the center line to end the autonomous period. And now we are seeing some more activity. ED Robotics looking to deposit a note into their red amp as well. And 2053 STR already getting another one into their red speaker. But what's that? The robotic Rams want to get in the way, fighting for that note. But it looks like STR was able to grab it nonetheless. On the blue wing, we have 3986 Espresso near their stage with a note lined up. in their intake. Will they deposit it into their amp or speaker? We've seen a lot of speaker action, but you can't exactly amplify without the amp. And 9750 ED knows that by depositing a note into their red speaker. And it seems both teams have elected to go for the cooperation bonus. The Red Alliance already 2/3 of the way towards that ranking point with notes, but now it is, as human players should be throwing them to try to spotlight the microphones. 3986 shooting one more time before lining up for a climb. 2053 looking for a climb as well. It looks successful. And 63-28. Acquiring the melody.
That's it. We had our robot diagram, right? Back one. Didn't we? Yeah. Frank, do you want to talk about this? I mean, I can if you want me to.
So this is our robot. The robot is, we refer to it as Bruin. It is 2.5 feet in size. The weight was, it ended up being 105 pounds, I think, and then the max speed is about 18 feet per second. So there's a bunch of different mechanisms we have on the robot. The drive base is what has the actual wheels and motors that allows the robot to move. It's what we call a swerve drive base, so it allows the robot to move forward and backwards and side to side, but also spin at the same time, so we're allowed to maneuver much better. Then we have the intake, which is comprised of wheels that have belts that allow the note to get sucked up into the robot, and then it holds the note there until it's ready to be pushed into the shooter. So the spinner is composed of, we have four spinning wheels, and the wheels will spin up, and once the wheels hit a certain speed, the intake will feed the note into the shooter, and the shooter will launch the note into the speaker, which is the big game piece that was at the back of the field. We also have what we call the dunker mechanism, and the dunker mechanism will extend out and works with the shooter. So the shooter will shoot the note into our dunker, and the dunker will redirect the note down into the amp, which was the game piece that was more on the field level. So that's the different parts of the robot and how it works.
Questions? Are there any questions?
My microphone isn't working. Oh, are there any questions?
How many different
Here,
controllers?
they usually want to.
How many different controllers are required to operate it?
We do.
Sure. So we have 2 controllers, and what we use are Xbox Series X controllers. And so I was the driver for the competition. So my controls, I have this stick, which would move the robot forward and backward, and then this stick, which would allow me to spin the robot. And then our operator would also have a controller like this, and then
The chamber, the speaker thing on the field that was in our practice video.
I meant to say chamber, sorry.
Yeah, that
on the robot.
on the robot.
Yeah.
Can you come up and point to what you're asking about?
So what did these do again?
Those hooks. Okay, so when we go into the game, right, we have that the big piece that stands in the middle, and there's that chain that goes across. So at the end, the robot has to drive up and it has to climb on. So these go up, and they're locked in right now, so we can't bring them up. But they go up, and then there's a motor that sucks them back down. So that's how our robot climbs up the chain. So it has to be not touching the ground for 5 seconds after the buzzer goes off for us to get those points.
Can
Can you do demonstrations of anything with this robot?
I think we can.
Yeah, so it'll take a second for the robot to like boot up and, you know, get connected to the driver station, which is what we use to control the robot. So our one of the cool parts about our robot this year that not a lot of other teams had. Normally our programming student would talk about it, but they're not here right now, so I'll give a little bit of an overview. So we actually have 5 cameras on our robot, one on each corner of the drive base, and they're able to detect April tags, which are like little QR codes on the field that with some fancy math, we can calculate where the robot is on the field at all times. So that allows us to do some fancy automation. So for our autonomous mode, we can tell it to drive to a certain spot on the field, or even in teleoperated mode, we had a button that the driver would press, and it would automatically drive to our ideal shot location. And that was really useful for speeding up how fast we could score. And that's, you know, obviously a major part of the game. You want the mic? I'll see if I can
So,
drive through.
hang on. I can. These are the April tags too, if anybody's wondering what they look like.
So we're able to pick up the notes. So as you can see there, you want to just go over what I'm doing with the robot? So
Yeah, so currently the note is intaked, and that's where it sits when we move across the field. So we'll go across the field. So there's something called the source where people can drop the notes down on the field. And so we'll drive up, and the operator will hit the intake button, and we'll just drive over it, and the rollers will suck it up, and it'll store it there until we're ready to shoot.
So when I'm going to try to shoot the notes.
All right. So he's going to try and shoot the note, although slowly. So those 4 orange wheels will spin up, and then the like belts in the intake will push the note into the wheels. So that's what shoots it. And then next, I'm going to do the dunker mechanism. So that's for the amp. So it'll actually shoot it into the amp mechanism. So the wheels will, for the shooter, will spin up, and then there's a motor mounted on the dunker. So the dunker wheels will also spin, and the dunker wheels serve to redirect the note down to shoot it into the amp.
That's really all we can. Like we can't run the climate.
Do you guys have any more questions?
I can. So our power source is, if you don't run me over, our power source is these batteries that are this gray car battery looking thing, except it's way smaller than a car battery. They're standard to the competition, so nobody can have like, you know, crazy power or anything that they're going to bring to competition with them. But those only last us about a match. We've never had one die during competition, but it has happened to other teams. We do have to check it. We have a thing we check it with. We always check them before we put them on the robot before a match, but we do go through like 5 of them during practices sometimes. So, yeah.
Does your school have multiple tournaments or something?
So our competitions are through FIRST, which is a big international organization. So we don't compete through the school. The school is just our like hosting organization. So the school helps us, they sponsor us, they let us use their site, they let us use they paid for some of our transportation this year. So they help us a lot, and they're in our, so we're their team, but we compete through other organizations.
So can you like walk us through when you start to enter the competition, they give you specs on what the game is. Can you walk us through what some of those parameters and criteria are for the robot?
For the robot?
Yeah.
So this year we had some rules, like we weren't allowed to extend anything beyond 6 inches outside of the frame of the robot. What other rules were they? That was one that we had a problem with, because picking up the rings is kind of complicated. They're not on the robot right now. They're on here. The bumpers that go around it have to be 7 inches with the bumpers on, and we weren't allowed to have any gaps in the bumpers this year, more than like 1 inch, which is a change in the rules from last year. So getting a ring under the bumpers was hard. We only had like a 1/4 inch extra clearance this year to get the ring under the bumpers, so that was a big change for us.
So the rule book that they give out is a lot more specific. Like, it's 200 something pages about what motors you can use, what batteries you can use, how much your robot can weigh, how big it can be, how far it can extend outside, and a bunch of gameplay rules as well, like what you can do in a match, what you're not allowed to do. So during the first couple days of the build season, the whole team gets together and reads the manual from front to back to understand the game fully, so we're able to design the best robot for that game.
Any other questions?
Who decides to drive the robot?
The person asked, how do we decide who drives the robot? And that's kind of a good question. Basically, you see who's the best and who has the most practice, and also being a driver is probably one of the hardest jobs at competition because you're under a lot of pressure to perform well, but you also have to be super nice to the other teams because you could be with them one match and then against them the next match. So being able to work with others and communicate clearly is really important.
So part of the structure of the for somebody's toes, like during practice, we have a really cramped practice area, so sometimes accidents happen. Like,
Sorry, I have another question. So this is the finished product, but how much of the design was worked out on paper versus trial and error later?
So our team tries to do as many real-to-life prototypes as possible. So during the first week, when we first get the game piece, we're using wood and wheels that we already have to try and prototype certain stuff. And then once we figure out and iterate on those prototypes, that goes into CAD, and then that gets ready. It gets put into the, quote, real robot CAD, and then that gets made. Sometimes things don't work, so we iterate again. So, for example, our dunker mechanism, in our CAD, we didn't have this last set of wheels out here, so when the note would come through, it would kind of shoot it more out than down, and we didn't realize that, so we ended up having to recut these and add this 4th set of wheels, but ended up working. So like a lot of because you have such a short amount of time, a lot of the process is just iterating on what you had already, because building something from scratch every single time is really difficult.
What I mean, a lot of the movements and the mechanics.
Oh, okay.
Did you work that out?
Yeah.
On paper? Because I'm seeing there's a lot of mechanics. I'm just trying to get a sense for how you go about that.
So, at least for the dunker, it's formerly called a 4-bar linkage. So, what we did for our prototype is we knew that we wanted to, like, we had this wheel set up, but not on the arm. And so when we brought that into CAD, we were like, okay, so how do we have to start this inside the frame perimeter of the robot according to the rules. So how do we get it from here to here? So what we did was basically sketch out the 2 positions we wanted that set of arms to be in. And then using CAD, we were able to design a 4-bar linkage that accomplishes this movement. And we went back and forth a couple of times if we wanted to use like a 4-bar linkage like this, or have like a linear sliding mechanism. But we went with the 4-bar just because it was simple and easier to package, I believe. It's been a month or 2 now.
I forgot, how long did it take to build this robot?
The robot was totally built in 6 weeks. We've made improvements since then, and we've changed things. But from our kickoff event where we saw that game video that we showed you guys a little bit ago, to the first time we had it in active competition, it was only 6 weeks. How much time? So our practices, how much time in those weeks was the question asked. Our practices, during those 6 weeks, we have a practice from 8 to 1 on Saturdays, and every other weekday we have a 3-hour long practice. So we spend a lot of hours working on this robot, and there are a lot of us who are working on it. Yeah, and there's people work on stuff at home, especially CAD, because we have to get CAD done really fast to build this and make sure it's working in 6 weeks.
Onshape. The question was, what CAD software do we use?
We use the Onshape CAD software because that's what we have available.
We did use Inventor in the past, but Onshape is like fully in the cloud, and it's really easy for students to work together. So we use Fusion for our CAM because Onshape doesn't have CAM right now, but Onshape specifically has a lot of FRC specific stuff that make it really easy to use, so we end up going with that. Yeah. Yeah, I mean, it's just a preference thing.
What are the tubes on the dumper made out of?
Can you come point to it again?
Are you talking about these? Oh, okay.
The wheels?
Yeah.
Or these things?
Oh, I guess both of them.
So the little wheels here are rubber. And the spacers we had to 3D print because we couldn't find spacers that were the right distance and enough of them. So we designed and printed all of those parts.
Any other questions?
I have one.
Yeah.
So, were all of you guys already interested in engineering prior to this, or were you interested in other backgrounds and then after getting involved with this, developed an interest?
I mean, I think most of I don't know, I was interested in this stuff before I joined the team. I think most of, yeah.
So I had wanted to go into science. I wasn't quite sure yet when I joined the team. I mean, I saw the robot looked really cool, and it seemed like a fun thing to do. I was kind of thinking more towards engineering, but I was also thinking about doing something in like biology or chemistry. But when I joined the team, I decided I wanted to go into engineering. So I'm going to college next year, and I'm going for mechanical engineering, and I feel like that's largely because of my participation in robotics that I'm decided to do that.
So we actually run a student survey at the end of each year, and we ask a lot of those kinds of questions. So a a lot of our, I don't remember the exact numbers, but I know we had at least a couple of people out of the 20-something so kids that answered that they basically, the survey asked what you said. And we had a couple, I think maybe 4 kids answer like they weren't sure what they wanted to do when they joined, but now they want to do a career in STEM. So that's one of the like results I'm really happy about this year because you know, that's the whole point of being first. So
Are there any other questions?
feel free afterwards, I'll get to your question in a second. Feel free afterwards just to come up and look at the robot or ask other questions.
Microphone.
How strong are the hooks?
How strong are the hooks? How strong are the hooks? I don't know. They hold up the 120-pound robot.
The hooks are pretty strong. The robot itself is like 105 pounds, and the hooks had no problem pulling it up. And we bashed the hooks pretty bad. Like if you look at it from close up, you can see that they're pretty heavily scratched because sometimes you'd like run into stuff or hit stuff, so they held up really well.
Yeah.
Well, anyway, I want to thank the entire team here. Actually, did you actually get a chance to introduce all the team members?
So, Ann is our business lead.
They can introduce themselves.
Oh, yeah. Okay.
Everybody come.
Obviously, this isn't the whole team. These were just the people that were able to come tonight, but I'll pass the mic around and let them introduce themselves.
I'm Luke. I participated in a lot of the wiring of this robot, along with other team members who aren't here today.
My name's Sam Winans. I'm the team co-captain, and I did the majority of the manufacturing and like machining to make any of the parts on the robot. So.
My name's Ann Coleman. I am the business and media lead, and I manage all of the team's fundraising, so we can do all of this.
I'm Frank. I'm the driver of the robot, but I'm also the manufacturing lead. So I helped with a lot of the assembly of the robot, and I worked with Sam to do a lot of the machining and production of the parts.
I'm Izzy. I'm on the electrical team. I helped with some of the wiring and some of the building of the field elements and whatever needed help.
My name is Mason McConnell, and I was on our CAD team, so I made all of our, well, not all of them, but models for our robot and some of the parts that are on it.
All right. We're good with the intros.
Okay. I don't know what.
Well, thank you. And actually, I will say that my daughter was on this competition team, and now she is finishing up her last year in computer science at in Boston. So good work. Anyway, thank you again for coming up here. I know it's a lot of effort to pull this together. For I know you finally get through competition, like we're done. But then like, no, we got to go to Kopernik. And so again, you feel free to come on up, ask some more questions. Again, especially for those people who've not been here before, we'd be very happy to give you a tour of the scopes. And also, if you paid to get in, you get, if you go back to the gift shop, they will give you a card to come back again on another night. So we'll get you to look through a scope yet. So anyway, thanks again. Next week actually will be we're going to be sort of tie the ribbons on the whole eclipse thing. There was a team of one of our educators and also some college students that participated in a thing called the Einstein Project, and they actually went to totality and prepared for that. And so they will talk about their the work that they did and the results that they saw or didn't. You'll have to come and find out. And but then if you go to our website again, you'll see that we have a number of other programs again every Friday night. Look forward to having you back here. And again, tomorrow is Brain Day. So especially those people with with kids between second grade and high school. We got some exciting camps. Two camps actually I'll mention is one that we do is called Welcome Aboard the International Space Station, where students learn what kind of work, what kind of training astronauts go through, what kind of work they do on the ISS. And then we've actually arranged with NASA to have our students talk to and ask questions of an astronaut on the ISS as they're flying by. We have a ham radio station here that we use to do that communication, and so it's our ham radio station that talks to the ham radio station aboard the ISS. And then also later in the summer we have another program called we've got a couple of them. We have one on virtual reality where the students will learn about VR and AR and create their own VR experience. And then we also have a final one that it's called Return to the Edge of Space, where they will put a payload together, put on a weather balloon that flies up to over 100,000 feet, almost 20 miles high. And then once the balloon pops, it gently, well, sort of gently, comes down to Earth, and then the team recovers it and looks at the video. So a lot of good stuff coming on this summer. Art. Right, and this project, this wouldn't happen if it wasn't for the adult mentors that are involved. So if this kind of thing has some interest for you and you think you can contribute, talk to Art and Drew and see if there's some synergy there that you might be able to take advantage of. So, all right, well, thanks again. It's great to see you here, and look forward to seeing you next week.